We said that two vectors are orthogonal if the scalar product of the two vectors is equal to 0. Today we're going to look at an application involving orthogonal vectors. This application is called the equation of a plane. Now I'm sure you've seen equations of planes before, so this should be a review, but we're also going to look at it in terms of orthogonal vectors. So maybe that's going to be a little new to you. So say we have 2 points, P1 and P2 in three-dimensional space. And the vector from P1 to P2 is usually denoted like this. You have a little arrow above it, P1 first and then P2. And all you have to do is take P2 and subtract P1. Now, points are going to be written as row vectors and like row matrices, and a vector in three-dimensional space is going to be written as a column matrix. Okay, so that way we can try not to get them confused. So when we see a point, it's always going to look like this, or it's a row matrix. And when we're talking about vectors, we're going to see a column matrix, or we're going to see a row matrix with a transpose. So what I said was, this vector from P1 to P2, all you have to do is take P2, each one of these entries, and subtract these entries from it. So 1 minus 3, 8 minus 2, and negative 1 minus 1, transpose, because it's a vector. So this is negative 2, 6, negative 2, transpose. You can leave it like that, or you can write it, if you like, as a column matrix. Okay. How do we find the equation of a line through 2 points? Now, in two-dimensional space, this is easy. It usually looks like y is equal to x plus 2 or something like that. But in three-dimensional space, it's a little bit trickier. So what we need is a directional vector and a point. And I'm going to use the example we just saw a minute ago. And this point needs to, you want it to lie on the line. So the directional vector is going to come from that point and another point that you want to lie on the line. So for our example, these were the 2 points. I'm going to write them down here. And then we said that the vector from P1 to P2 is negative 2, 6, negative 2. So the line through these 2 points, we're going to call it the line L. All we do is we take the vector, this negative 2, 6, 2 transpose, multiply it by a variable. I'm going to multiply it by t, and then we add either one of these points to it. So I'm going to go with 3, 2, 1, but make sure you put a little transpose. That way you can add the matrices. So this would be the vector form of the line. And of course, if you want to figure out the points that lie on the line, well, you could say the line looks like x comma y comma z. And then from that, you can see that your x is going to be negative 2t plus 3, just by looking at the x part. Y is equal to 6t plus 2. And z is equal to 2t plus 1. And that's how you can get the points on the line. Okay, moving on from that, let's talk about finding the equation of a plane. So if you have a fixed point and a non-zero vector n, which we call the normal vector, the set of points such that this vector with the normal vector, if you take the inner product and you get 0, that's what forms a plane. And that gives you the equation of a plane in R3. So what you're going to do is you're going to find all the points. So you come up with this vector here that contains these points. And you're going to take the inner product with n and set it equal to 0 and that will give you your equation. So let's do an example. To me, it helps me if I see this so I can figure out what I'm doing. So say we have this as our normal vector, 2, 3, 4, transpose, and this is a point that we want to lie on the plane. So we want to find the plane through this point, and it's normal to this vector. So let's find a vector that contains, let's find a vector that we use this point with to find. That makes sense. So I'm going to come up with a vector using this point. So let's call it P0, P. And what I'm going to do is I'm going to, let's say P is the point X, Y, Z that we want to lie on the plane. And we just take X and subtract 1. So I'm taking this one and subtracting this one. Remember how we find the vector. And then this one minus this one. So this is Y minus a negative, which becomes Y plus 1. And then Z minus 0, which is just Z. Okay? And now we want to take the inner product of this vector with this vector and set it equal to 0. That way they are orthogonal. Okay, let's do that. So we're going to take the inner product of P0P with N. Remember, that is P0P transpose times N. Okay, so this is so remember, so we don't get confused, P0P is X minus 1, Y plus 1, Z. And this is its transpose, so let's write that. And we're going to multiply it by N, which is 2, 3, 4. Because this is the transpose, that's what N is. And we want that to equal 0. So let's multiply it out. I'm not going to distribute anything. I get 2 times X minus 1 plus 3 times Y plus 1 plus 4 times Z is equal to 0. And this is the equation of the plane that passes through the point 1, 1, 1, negative 1, 0, and it's normal to this vector. And you probably learned, maybe in Calc 3, that you just put the normal vector here, and then you put the point inside the parentheses with X, Y, and Z. So you subtract the point, so here would be Z minus 0, so just Z. And this is where that equation came from. You have to take this dot product and set it equal to 0. Okay, so sometimes we're not given a normal vector, but we're given 3 points that are not collinear. Well, from those 3 points, you can find a plane. I'm going to show you how to do that. So let's say these are the 3 points we're given, P0, P1, and P2. I want to come up with the equation of a plane, so what I need to do is I need to find a normal vector. How I'm going to do that is first I'm going to come up with 2 vectors. I'm going to use P0, P1, and it doesn't really matter if you use P0, P2 or P1, P2. I'm going to go with, let's go with P1, P2. So let's just come up with these 2 vectors. So we're going to get 0 minus 1, 1 minus 2, and 0 minus 1, which is negative 1, negative 1, negative 1. And then this vector is 1 minus 0, 1 minus 1, and 5 minus 0, 1, 0, 5. Okay. And now I have two vectors that I want to lie on the plane, but I want to find a vector that's normal to both of these. So how do I do that? So I want this vector n, where we get n, the inner product of it with p0, p1 is 0, but at the same time, the inner product with p1, p2 is also 0. How do we find this vector n? So I need it to be orthogonal to both of these. It may have been a while, but to find a vector that's orthogonal to two vectors, you use the cross product. So let's write that down, the cross product. And we write it like this to find the cross product. And what you do to find the cross product is you make this matrix, but with straight lines here. We put I, J, and K. And then we put this vector underneath it as a row vector. And then we put this one in the last row. So I'm going to put -1, -1, -1, and 1, 0, 5. And what you're going to do is you're going to take the determinant of this matrix. That's why I have straight lines here. That means take the determinant of this matrix. So how do we take the determinant of the matrix? Well, remember what the determinant is. You can go along any row or column you want, but it's best to go along this one. So we get I, then we cross this one out and this one out, times -5 minus 0, and then subtract J, cross this one out and this one out, and -5 minus a -1 plus K, and we get a 0 minus a -1, and we're left with -5I. This becomes -5 plus 1, so 4J, because this is a -4, and then you got this negative, and then it looks like we have a K. And you can put a 1 there if you want. So n is going to be -5, 4, 1 transpose. And the reason for this negative is because of what you do when you take the determinant. Remember that this entry is the 1, 1 entry, so 1 plus 1 is 2, so you get a positive, and if you get an odd number, like 1 plus 2 is 3, then you get a negative. So you might want to review how to take a determinant if you don't remember that. Okay, so now I have a normal vector, and I also have 3 points. So to figure out the equation of the plane that involves these 3 points, well, I take the normal vector and I choose one of the points, and I just take the inner product of those two. So I'm going to, the inner product, we can write it like this. So -5 x minus something plus 4 y minus something plus 1 z minus something is 0, where this is your normal vector. And then you plug in a point here, and you can just plug in this point 1, 2, 1, or you can do 0, 1, 0, 1, 1, 5. It doesn't matter. So 1, 2, 1.